Inequalities. A polynomial function is positive, negative, or 0 for all real numbers x, but a rational function can be positive, negative, 0, or undefined. Okay, remember you cannot divide by 0. So in particular, rational function is undefined if the zeros of the denominator. So when solving rational inequalities, we modify the kind of sign chart using example 1 to include the real zeros of both the numerator and the denominator as locations of potential sign change. Okay, so we're going to have to do A for 0, undefined, positive, and negative. Super easy. Okay, now I want you to think. Make your sign chart. Okay, what are my critical points? Well, where's the top going to be 0? Negative 1/2. Where's the bottom going to be 0? Negative 3, and then 1. So put it in order. Negative 3, negative 1/2, and 1. Now, the other thing we have to mention is, where is it 0, where is it undefined? So at negative 3 comes from here, so it'll be undefined at negative 3. It'll be 0 at negative 1/2, and it'll be undefined at 1. Now, Alex, what's a number less than negative 3? Okay, so Alex, if I put negative 4 on the top here, Alex, is it going to be positive or negative?
On top?
Yep. Good. If I put negative 4 here, Alex, it's going to be positive or negative. And x plus 3. If I put negative 4 into the x minus 1, it's going to be positive or negative. Good. So we'll have negative divided by negative, negative, right? How many negative signs do I have? 3, correct? Is that odd or even? Odd. So if you have an odd number of negative signs, it will be negative. PJ, give me a number between negative 3 and negative 1/2. Okay, PJ, if I put negative 2 up here, am I going to get positive or negative? On the top. I'll get negative, right? If I put negative here, or negative 2 here, it's going to be positive or negative. And x plus 3. It's going to be positive. If I put negative 2 here, it'll be negative. So right now, how many negative signs do I have? I have 2. It tells me it's even. Will be a positive answer here. So I'm going to have a negative divided by a negative will be positive. Okay? Seidel, number between negative 1/2 and 1. Okay. I will say this, 1/2 is fine. We can use that, but every time that you can use 0, I would suggest using 0 because that'll make it super easy. Does that make sense?
Oh, yeah.
So, we're going to put 0 in here. Be positive, and a positive negative, right? So I have a positive divided by a negative will be negative. Now the last one, a number greater than 1 would be 2, positive, positive, positive. Which tells me positive here. Now for part A, it's going to be 0 where? Where is it going to be 0? Okay, it's only going to be 0 at negative 1/2. Where is it going to be undefined? Negative 3 and 1. Where is it going to be positive? It's going to be positive between negative 3 and negative 1/2. In union with 1 to infinity. And it's going to be negative from negative infinity, negative 3. In union with negative 1/2, 1. Okay? Are there any questions how we found where it's 0, undefined, positive, negative? There's no questions at all? Okay. I'd like you guys to work on B. All right, when we look at this, again, what we'll have, our critical points will be negative 3 over 2, 1, and 4. Remember, when you do these, though, you have to have them in numerical order, least to greatest. Now, negative 3 halves will be undefined because you can't divide by 0. It'll be 0 at 1 and undefined at 4. Now, a number less than negative 3 halves or less than negative 1 1/2 would be negative 2, which means it'll be negative on top, negative and negative on the bottom, which means we'll be negative here. In between negative 3 halves and 1, we can choose 0, be negative on top, positive, negative, which means it'll be positive. In between, what's that? What's that?
Doesn't matter where you write the answer.
No.
Wait, I have a question. I thought there's 2 negatives and 1 positive.
That's a negative divided by a negative. Negative divided by negative will be positive. Okay, a number between 1 and 4, say 2, be positive, divided by positive times a negative, which will be negative. And then the last one, greater than 4, we'll say 100, positive, positive, and positive. Which means we positive. Now, again, Seidel, like your question, it doesn't matter where you write your positive and negatives. It's just, I find it easier if you just write it above. So, yes, Mike.
How do you know that 1 is 0?
Because that will create 0 on top. Whoever creates 0 on top, that will be a 0. Whoever creates 0 on the denominator, that will be undefined. Okay? So when we do these, where is it 0? At 1. Where is it undefined? At negative 3 halves and 4. Where is it positive? In between negative 3 halves and 1. In union with 4 to infinity. And it'll be negative from negative infinity to negative 3 halves. In union with 1 to 4. Now again, if you graph this, which I suggest you do, so everyone take out their calculator and graph it. Now if you notice though, I did put the double parenthesis here. Okay, I did put the double parenthesis on our denominator, so your calculator knows I'm dividing by that product. Okay, that's really what's going on there. You're dividing by that product. So it's going to be parenthesis 2x plus 3 times x minus 4. We're going to graph that then. Okay, now you can see it'll be 0. And x equals 1. It'll be undefined at negative 3 divided by 2, because there's no y value there. It'll be undefined at 4. There is no y value there. So from negative 3 halves to 1, it'll be positive. And then also from 4 to infinity, it'll be positive. That'll be negative from negative infinity to negative 3 halves, and 1 to 4. That's where it'll be negative. So you can see it on your graph. Okay. Are there any questions on B right at this time? Next, we need to solve a rational inequality by combining fractions. So that's what we have to do here. So we need to combine the fractions. What's the common denominator between x plus 3 and x minus 1? X plus 3 times x minus 1, right? So we're going to multiply everything in here by x plus 3 times x minus 1. Which means if I multiply the x plus 3 times x minus 1 times this first fraction, I'll end up with 5 times x minus 1 plus 3 times x plus 3, right? Over x plus 3 times x minus 1. We want to see where that is less than 0. Okay? All I'm doing is combining fractions here. Yes, question? Okay. So when we simplify this, we'll end up with 5x minus 5 plus 3x
plus 9 over x plus 3 times x minus 1. And again, we want to see where it's less than 0. Which means if I combine like terms a little bit further, 5x plus 3x will be 8x plus 4 over x plus 3 times x minus 1. Let's see where that is less than 0.
Make sense so far? So we haven't done anything we haven't done before, right? We're just combining fractions. Now, our critical terms, our critical points, will be, what about from the top? What's it going to be? Negative 1/2. From the bottom, it's going to be negative 3 and positive 1. So we'll have this. Now, negative 3 will be undefined. Negative 1/2 comes from the numerator, so that will be 0. 1 will be undefined because you cannot have 0 in the denominator. Now, what is a number less than 3, Wes? Or it's less than negative 3, yes. Negative 4. So if I put negative 4 here, I'll get a negative, negative, and a negative. So I'll have 3 negatives. So an odd number of negatives tells me it is negative. Ashley, give me a number in between negative 3 and negative 1/2. Negative 2. Put negative 2 up here, I'll get a negative divided by a positive times a negative. How many negative signs do I have? 2 tells me it's even, which will be positive. The number between negative 1/2 and 1, Jim, is what? 0. So I'll put 0 up here, I'll get a positive divided by a positive times a negative, which will be negative. Then if I use a number greater than 1, let's say 10, I need positive, positive, positive for all these parts, which means they'll be positive. Now, we want to know where it's less than 0. So everywhere that you see a negative, that's where it's less than 0, correct? So our answer will look like negative infinity to negative 3 in union with negative 1/2 to 1. There's our answer. Are there any questions on that? All right. Please try example B. All right, going over example 6B here. Again, the common denominator will be x plus 1 times x minus 3, so it's going to be 1 times x minus 3 plus 1 times x plus 1 over x plus 1 times x minus 3. See where that is less than or equal to 0. Now, again, when it says less than or equal to 0, remember we're going to have brackets instead of parentheses here. So x minus 3 plus x plus 1, so we'll end up with 2x minus 2 over x plus 1 times x minus 3 less than or equal to 0. Now, when you make your sign chart, our critical points be 3, negative 1, and 1. Let's try that again. So a number less than negative 1 would be negative 2. Put negative 2 here, I'll get a negative on top, negative and a negative, which means it'll be negative. We're going to choose 0 for the next one, which means I'll be negative, positive, negative, which means I'll be positive here.
In between 1 and 3, let's choose 2, which means it'll be positive, positive, and negative. And it'll be negative. And then number greater than 3, let's choose 100. Be positive, positive, positive. Okay, now also we should know that negative 1 will be undefined, 1 will be a 0, 3 will be undefined. This will shape our answer. Now, because we want to see where it is less than or equal to 0, it means my answer will be negative infinity to negative 1. Now, am I going to put a bracket or a parenthesis on the negative 1? Careful, is it 0 or undefined at negative 1? It's undefined, so it's actually going to be a parenthesis here. In union with 1 to 3, 1 will have a bracket, 3 will have a parenthesis. Okay, so you do need to pay attention to that. Now, if we were to graph this, you can see where all this stuff is going to be. Okay, so you can see from negative infinity to negative 1, it'll be less than 0. Correct? So that's what we have there. The next part will be from 1 to 3. From 1 until 3, it'll be also less than 0. Or less than or equal to 0. Okay? Are there any quick questions on example 6b? Now, in examples 5 and 6, those are rational equations and polynomial equations, things like that. We're going to talk about other inequalities here in examples 7 and 8. Now, the sign chart method can be adapted to solve other types of inequalities, and we can support our solutions graphically as needed or desired. Okay? Now, I want you to think about this. What are my critical points here in example 7a? We're going to have 3 and negative 1, right? So make sure you write these down. Now, remember, you cannot take the square root of a negative number. What's going to make this negative? What's going to make the stuff underneath the square root negative? Anything less than negative 1. So all the stuff this way is undefined until negative 1. We'll have a 0 here and a 0 here. So I don't have to worry about anything left of negative 1. Make sense? Now, what's the number between negative 1 and 3? Same process. Number between negative 1 and 3. So anyway, you got? Okay, good. Remember, anytime you can choose 0, choose 0. So, put 0 here, what do you get? You put 0 in for x here, you get negative 3. Put 0 in here, you get 1. So I have a negative times a positive. What's a negative times a positive? It is a negative. Now, a number greater than 3, let's choose 1,000. Be positive and positive here, which means I'll be positive. Now, where is this thing greater than or equal to 0? Well, it's greater than 0 from 3 to infinity, right? Where is it equal to 0? It's equal to 0 at negative 1 and 3. So our solution will actually be this. Braces negative 1 in union with bracket 3 to infinity. Do the best you can on the braces, but remember, once you get into higher level mathematics, you will be using these a heck of a lot. Now, it might look to you like it's not actually going to touch the negative 1, right? Okay, but you can see where it's going to be greater than 0 from 3 to infinity. But if I do a second trace and I do a value at -1, you'll see that it actually will give you a value of -1, 0. Okay, so this answer is correct. What I'd like you to do, I'd like you to try example B. A lot of the same stuff, so it shouldn't be anything new to you. Okay, please try example B. Now, if we look at these, in example B, our critical points, in this case, our zeros, will be -4 and then 1/2. Remember, anything less than -4 is undefined, so don't have to worry about that either. Okay? -4 and 1/2 will be my zeros also. Now, a number between -4 and 1/2 would be 0. Put 0 here, you get positive, or sorry, you get negative. Put 0 here, you get positive. Okay, which would be negative. Now, a number greater than 1/2 will be 10, positive and positive, which means I'll be positive. Now, we want to see where this thing is less than 0. Well, the only place where it's less than 0 is between -4 1/2. So your answer be -4 to 1/2. Now, again, if you were to graph this, you can see it's actually going to be -4 here, so it's going to be 0, so it's going to come here. That's where it's less than 0. Okay. Now, moving on to example 8. Solving an inequality involving absolute value. Solve the inequality. So, what are our critical points? Critical points are 2 and -3, right? Remember, if you put -3 here, what are you going to get? If you put -3 in the denominator, what are you going to get? You're going to get 0, so that's not a good thing. Okay, because you don't want 0, so that's still why it's a critical point. However, it will be undefined at -3. It will be 0 at +2. Now, what's a number less than -3? -17.5. Good, Ben. So if I put -17.5 in here, Ben, what am I going to have? Negative. Put -17.5 in here. You're going to get negative on top. You're going to get the absolute value of a negative on the bottom, right? So what's a negative divided by a positive? That would be negative there. Okay? What's the number between -3 and +2? 0. So if I put 0 in here, I'll get negative on top. I'll get a positive on the bottom, which means I'll still be negative, correct? Jacob Norrell, give me a number greater than 2. 300. So if I put 300 in here, what am I going to get? Here? So I have a positive divided by positive, right? Which means I will be positive. Now, where is this thing less than or equal to 0? Well, it's less than 0 here and here. It is equal to 0 here at the 2. So my answer will be -infinity to -3 in union with -3 to 2 with a bracket. Are there any questions on example 8A? Yes, Justin.
Why can't you just go from -infinity to
You can't do that because it is undefined at -3. That's why you can't go -infinity to 2. I'd like you guys to work on B.
Now we do these. Remember, you should be able to figure out your critical points here. So a 5, 2, and then 3/2. Now, I don't think I've ever said this, but remember to put them in order from least to greatest, so make a heck of a lot more sense. So and remember, when we have the square root on the bottom, well, let's do this. This will be undefined. We'll have a 0 here and a 0 here. Because the square root's on the bottom, anything left of 3/2 will be undefined. So we don't have to worry about anything left of 3/2. A number between 1 1/2 and 2, say 1 3/4, will be negative. The absolute value of a negative. And then the square root of a positive, which means they'll be positive. So really I have a negative times a positive divided by a positive, which will be negative. Now it seems like a lot of thinking there, but we should be okay. Number between 2 and 5 would say 3, be negative, absolute value of a positive, and a positive, which means I'll be negative down here. Number greater than 5, let's say 10, which means I'll be positive, absolute value of a positive, and a positive, which means it'll be positive there. Now, where is this greater than or equal to 0? Well, it is equal to 0 here, and it is greater than 0 here. So my answer, 2 in union with bracket 5 to infinity, because it's also equal to 0.
Are there any questions right this second on anything that we've done today?
If you got rid of that square root, would it still be undefined?
Yes, it'd still be undefined. Even if the square root wasn't here, we'd still be undefined at 3/2.
It's only changing a lot.
It just says you can't, nothing left of negative 3/2, or nothing left of 3/2 matters in this case because it's undefined. Okay? Any other questions on examples 5, 6, 7, and 8?